Welcome friends. So we have discussed resistance and inductance, brief idea of resistance and inductance. Now in this part we shall discuss another important parameter or component of the electrical network, which is capacitance. Now a capacitance, what is a capacitance? A capacitance is given by this symbol, just like two parallel lines like this. Now what does it signify? It signifies they are actually two plates, two metal plates. So if two metal plates is separated by a dielectric medium, now in between it is a dielectric medium. Dielectric medium, it may be air, it may be paper, whatever, any dielectric medium. Now this arrangement is called a capacitor. This arrangement, this when two plates is separated by a dielectric medium, this arrangement is called a capacitor. Basically it deals with it is a charge storing device. It stores its charge. Now when a voltage is applied across a capacitor, then a charge will be stored. Now if you increase the voltage, charge storing capacity will be increased. So there is a direct relation, that is the charge storing capability of that arrangement is directly proportional to the voltage applied. So due to that fact, we can bring a proportionality constant which is equal to C. So that is where from we have got a very well-known relation, Q is equal to Cv. So what is C? C is equal to Q by V, that is charge storing capacity per unit voltage. So it is actually unit in farad, farad. Now in case of this type of capacitor, it is called parallel plate capacitor. This type of capacitor is called parallel plate capacitor. If that parallel plate capacitor has the distance between two plates is L, or let us say more well-known form of symbol, that is D, and this area of this plate is A, area of the cross section, then capacitor of a parallel plate capacitor is given by epsilon A by D. This is another well-known relation studied in school level physics. What is this epsilon? Epsilon is called permittivity of the dielectric medium. A is the cross sectional area and D is the gap distance between two plates. Now what is epsilon? Epsilon has two components. One is epsilon naught, another one is epsilon r. So epsilon naught is 8.854 into 10 to the power minus 12 farad per meter. It is called absolute permittivity. It is called absolute permittivity. Now in case of magnetic circuit, we have seen mu naught, that is called, it was absolute permeability. Absolute permeability. Now in case of capacitor, we are seeing now absolute permittivity. Absolute permittivity. And epsilon r is called relative permittivity. It depends medium to medium. Epsilon r is relative permittivity. It depends from medium to medium. It is 1 for air and have some finite value for other dielectric mediums. We have a series and parallel capacitance combination, just we have seen in case of a resistance and inductance. So if two capacitors C1 and C2 connected in series and our current is flowing, then equivalent capacitance is given by this formula, C1 C2 by C1 plus C2. So in case of series capacitive circuit, it is C1 C2 divided by C1 plus C2. Whereas in case of a parallel circuit, two capacitors C1 and C2 are connected in parallel, so equivalent capacitance is the summation of two capacitors. So it is C1 plus C2. So now you can understand that these relations are exactly opposite with respect to resistance and inductance. So for series capacitor, it is C1 C2 plus C1 C2 divided by C1 plus C2, and for parallel capacitor it is summation of C1 plus C2. Now to briefly summarize, let us say now capacitance is formed when two metal plates is separated by a dielectric. So it is formed simply, we require two metal plates and in between we should have a dielectric medium. Now unit is microfarad. Now what is the difference between farad and microfarad? So here I have mentioned that the unit of the capacitance is farad, and here it is written microfarad. Now micro means 10 to the power minus 6. Now in order to develop a capacitor of farad rating, suppose you need to develop a 1 farad rating capacitor, 1 farad rating capacitor. So its actually physical size is extremely large. Extremely large. So it is almost not practical to achieve. It is not practical to achieve. Okay. Not practical to achieve. So due to this reason, the practical unit of the capacitance, you can say it is microfarad or nanofarad or picofarad, whatever it may be. Microfarad or nanofarad or picofarad. Because if you use farad, so physical size of that capacitor is so large that is impractical to achieve. So that is why normally we use the unit of the capacitance as microfarad or nanofarad or picofarad. Micro means 10 to the power minus 6, nano means 10 to the power minus 9, and pico means 10 to the power minus 12. So if you go with this dimension, then we can achieve the practical dimension of the capacitor. Okay, that is the most practical way of writing the units of the capacitor. Now the potential drop across the capacitor given by this formula, 1 by C integration 0 to T IT dt. We shall we shall use this expression later on of this course. Now power dissipated in the capacitor is 0. Again, so we have three parameters, R, L and C. We have two powers, active power, which is P, and we have reactive power, Q. So in case of a resistance, we have mentioned active power is dissipated by I square R and reactive power is 0. Inductance, active power is 0, reactive power it always absorbs. Now in case of a capacitance, power dissipated it is 0. So active power again it is 0 for capacitor, However, for reactive power, it always deliver. A capacitor always delivers reactive power. That means it is delivered. So this is the difference between these three components in terms of power. Resistance always dissipates active power. It has no role in reactive power. Inductance, capacitance has no role in active power. Active power never dissipated in inductor and capacitor. Inductor always absorb reactive power, so it always takes. However, capacitor is always delivered. That means you can say capacitor is a reactive power generator. It always delivers. So due to this reason, sometimes absorption is called lagging var. Sometimes it is called lagging var. We have seen in case of an inductor. Now in case of a capacitor, it is called leading var. It is called leading var. So inductor always absorbs. However, capacitors always delivers reactive power. Now in case of an inductance, it was half Li square, but in case of energy stored in capacitor, it is half Cv square. Again, 10-12 standard well-known formula. Now capacitance of a parallel plate capacitor, it is very important. Epsilon A by D, it's very important. Now equivalent capacitance in series is given by this formula C1 C2 divided by C1 plus C2, and in case of a parallel connection, it is just the summation C1 plus C2. So since it is the just like two plates parallel, this arrangement, so the symbol of the capacitance is given like this. The idea comes from here. It is the symbol of the capacitance. So with this, let us end here for the capacitance calculation, and let us stop here. We shall see some more aspects of the preliminary ideas of network theory. Thank you.